T9.11. A software company is trying to decide whether to produce an upgrade of one of its programs. Customers would have to pay $100 for the upgrade. For the upgrade to be profitable, the company must sell it to more than 20% of their customers. The company will survey a random sample of 60 customers about the issue. Which would be a more serious mistake in this setting, a type 1 error or a type 2 error? Justify your answer. Okay. So, in order to describe the errors, we first need to describe the hypotheses. The null hypothesis would be that the true proportion of customers willing to upgrade is exactly 20%. And the alternative hypothesis is that the true proportion of customers willing to upgrade is more than 20%. Okay. So to put it in more contextual language, the null hypothesis is equivalent to the upgrade not being profitable. And then the alternative hypothesis is equivalent to saying that the upgrade would be profitable. Okay. All right. So now let's talk about type 1 and type 2 errors. Okay. A type 1 error, by definition, is that the null hypothesis is true, but we mistakenly reject the null hypothesis. Okay. So in context, I'll write this in green. This would be that only 20% of customers are going to upgrade, but we think it's somehow going to be profitable. Or we could just say, the upgrade is not going to be profitable, but we think that it will be. Okay. All right, a type 2 error, by definition, is when the alternative is true, but we fail to reject the null. So we kind of stick with the null. Fail to reject the null. So in context, that would be that the upgrade is going to be profitable, but we don't think it will be. All right. Now the question is not just to describe these, but to decide which one is a more serious mistake. So, what are the consequences of upgrading when it won't be profitable? Okay. So if we push forward with the upgrade, we're going to spend a lot of money producing the software, advertising it, marketing it, distributing it to stores, but not a whole lot of people are going to buy it. Okay, so we're going to spend all of our resources going for this upgrade, and we're not going to get the profits in return. And then we're also going to have a lot of extra leftover product, right? That's just sitting on shelves because nobody's buying it. Okay, so that doesn't sound too good, right? We're spending our resources, and we're not going to get the profits in return. Okay, so the company might lose money, lose investments from investors. I don't know. It just sounds bad money-wise decision. Okay. The type 2 error is the upgrade will be profitable, but we don't think it will be. So really the only thing here is just a missed opportunity, right? It would have been profitable, but we don't push forward with it. So there's a potential to earn money that we don't fulfill, right? But we don't lose money, right? We just miss an opportunity. Okay. So my opinion, and this could depend on your business perspective, but I would say the type 1 error is worse because the company will probably lose money. The type 2 error is not so bad, it's just a missed opportunity. Let's look at part B. In the company's survey, 16 customers are willing to pay $100 each for the upgrade. Do the sample data give convincing evidence that more than 20% of the company's customers are willing to purchase the upgrade? Carry out an appropriate test at the alpha equals 0.05 significance level. All right, so we're going to use the 4C method to do this. Okay. All right, here, let me see if I can just resize this and move it out of the way. Okay. All right, so let's start with the choose step. All right, so we want to start with the name of the procedure. This is a one sample z-test for a proportion. Okay, our parameter P is the true proportion of all customers willing to upgrade. Or who will upgrade. Okay. All right, our null hypothesis is that P is only 20%, and the alternative is that P is greater than 20%. Okay. Our significance level is 0.05. Our statistic, P hat, is 12 out of 60, which, did I get that right? Oh, no, not 12, 16, sorry, my mistake, 16 out of 60. Okay, 16 out of 60 is 0.266. I'll round it actually to 67. All right, so we have some evidence for the alternative because technically speaking, the sample proportion is greater than 20%, right? But is it significantly greater? We have to finish the rest of the test. All right, so let's check our conditions. Okay. All right, do we have a random sample? Yes, right here. Random sample of 60, so check. Excuse me. Do we meet the 10% rule? Okay. Well, I would safely assume that 60 customers is less than 10% of all customers. Okay. And then now we need to check the large counts condition. So n times p, that would be 12, and then n times 1 minus p would be 48, I think, yeah. Both of those are greater than 10. All right, so everything checks out, all our conditions are satisfied. Now we can move on to the calculate step. Okay. So start with a general formula, standardized test statistic is equal to a sample statistic minus the parameter divided by the SD. The specific formula for this procedure is p hat minus p divided by the square root of p, 1 minus p over n. Right, next we'll plug in the numbers. I'll just do it right here. So 0.267 minus 0.2 divided by the square root of 0.2 times 0.8 all over 60. Okay, and then we'll evaluate this on our calculator and get the test statistic. Okay, 267 minus 0.2, all right. I got 1.297, so let's round that to 1.30. All right, now we'll draw a picture. Here, I'm running out of space, so let me do this. Let's just resize you. Okay, so we'll draw a picture now. Standard normal distribution. Okay, and 1.30 would be over here. We're going to shade the right tail because we're looking for evidence that the true proportion is greater than. Okay, and then you can just use normal CDF now, or table A, to get the p-value. All right, I'm just going to do this off screen. Okay, so normal CDF, lower bound 1.30, upper bound 99999, 0.1. All right, p-value is 0.0968. All right. Time to write our conclusion. All right, so this p-value is not less than our significance level. All right, so it's not a statistically significant result. We failed to reject the null hypothesis. We have not found significant evidence that the true proportion of customers willing to upgrade is more than 20%. All right, let's write all that down. Since 0.0968 is greater than 0.05, we fail to reject the null hypothesis. We do not have convincing evidence that, okay, so let me use the language that they used. Convincing evidence that more than 20% of the company's customers are willing to purchase the upgrade. Okay, so we do not have evidence of that statement. That more than 20% of the company's customers are willing to purchase the upgrade. All right. So this question didn't provide us with the blueprint or the skeleton of the 4C method. We just have to remember what all those steps are. I know it's a lot, but with practice, it will become second nature. So name of the procedure, define the parameter, write the hypotheses, significance level, and the statistic. Okay, random 10% large counts conditions. Okay, general formula in words, specific formula in notation, plug in the numbers. Here's our test statistic. Here's our picture, which shows how we're getting our p-value. Right, and then we compare the p-value to the significance level, decide whether to reject or fail to reject the null, and then make a statement in context about whether we do, or in this case, do not have convincing evidence for the alternative.